normal bell curve. Your average is in the middle. And the standard deviation is how much you move up each time. So here's going to be 25, 28, 31, 19, 16, and 13. You only have to have those values on there because that's plus or minus 3 total standard deviations. When it says at most 25, at most means is it going to be more than 25 or less than 25?
Yes.
Less than 25. So it's everything going this way. Well, I know that in this section here is how much percentage? 0.34. And then how much is on this whole side then? 0.5. 50% is on the other side. So the answer here is? It's okay. It's okay. It's not a big deal. Remember, doing it in percents is actually one more step that you need that you can screw up.
Yeah.
So it's not that big of a deal, but that's all that means. So these, you're looking all crazy. It really is that easy. Okay? Because what happens here is these break down. That if 68% go here, this is a symmetrical curve, so it means this is a 0.34. This is a 0.34. If this much is 95%, you cut out the 68%, you're left with 0.135 for both of these. And this is 99.7, back it out. What were these, what was the third standard deviation?
0.02. It's 2.35%.
0.0.
It's 0.0. Well, 2.35% is the same thing.
And then the tails was 0.015?
00.
Was it 00?
Yeah.
No, I thought it was.
No, 00. I checked the book because I thought I was wrong.
Yeah. Yes.
And that's how your percentages work out. What's nice about a normal curve, these percentages don't change. The only thing that's going to change is your average and your standard deviation. That's what you might have heard where when they curve a test, a lot of times they curve it to a norm. So, sometimes it's beneficial, sometimes it's not. In statistics, there are many different distributions that you can look at. And what a lot of times they do is they try to get the distribution to go back to what's called the normal curve. Because if the distribution appears to be normal or it can be normed, you might hear that term at some point in a stats class, you know that these stat numbers will work. That's 68, 95, or 99.7. That's what statisticians look to be able to do because it makes things easier to work with. Okay? Now, what I want to look at real quick is just those three. You probably already have it done. What changes if you're trying to find 3 randomly selected things versus just 1? All you have to do is, you multiply it out 3 times, you just raise it to the power. So in where they're saying that you have a normal distribution of a mean of 64 and a standard deviation of 7, what are 3 randomly selected values are all 71 or greater. So we knew from the problem earlier that this much going this way was 0.84 because this was the mean and this was just up 1 standard deviation. So everything going to the left of that would be 0.84. How much is going to the right?
0.16.
0.16. So if I'm doing 3 of them, it would be 0.16 to the 3rd power. Or you can multiply it out 3 times. Okay? Does that make sense for those of you guys that were gone yesterday? I'm hoping that it's pretty simple. Okay. 4 randomly selected values are all 50 or less. Well, we got to bring down our 2 standard deviations. There's 50. So we want to be 50 or less. Let's see. So that was 68. Excuse me. So that was 84. We know it's 84 this way.
Where are the batteries?
In a box. Can you give me a minute? I can help you out. Let me take care of this first. Okay? And it's just a matter of working your percentages. So if there were, if this was at your 2nd standard deviation, you only had those 2 little chunks left off. You're looking at adding these 2 together and then multiplying it out 4 times. Okay. Make sense? Let me show you what it talks about with this approximation mumbo jumbo. I don't remember if it did it or not. Let me pull this up. So a lot of times what you can do, and I don't want you to write all this stuff out because this is more of an explanation as to why one of the things we've been working actually works for normal distributions, as opposed to having to do it the old-fashioned way, which is the way they had, because they didn't have these fancy calculators when the book was written. You actually had to do math. So what happened is that if you had a binomial distribution that had a really, really large sample size, so I can pull that up a little bit. When you have a large value of n, you can do, when you're working with binomial, remember that's how we would draw out all of our histograms. We'd have all those bar charts, and those bar charts over time, if it becomes really, really large, they started to stack up to look like the normal curve. Well, what they're able to do here is that they would norm it by this simple formula. That was able to calculate multiple values at the same time, whereas you guys have a button. That one we were talking about yesterday, that binom MCDF, the cumulative distribution function, it mirrors the same idea as normal approximation. It basically does the exact same thing. So what we can do, those guys were gone yesterday. We talked about, remember how we did that binom PDF and we send it to the list in the calculator and it would do all the work for you? Well, the CDF button on the calculator did the idea of adding up the columns. So remember how you do like, where your K value was less than or equal to 5, then you'd go through the table and add up those 6 terms for 0, 1, 2, 3, 4, and 5. Well, if you did it with this binom CDF, you would accumulate all those values for you. I didn't know that until the next day, and I figured out what that button did because I Googled it.
Wait, so which one did we use originally?
Originally, you used the PDF. The PDF is the one that sent you, if you were storing it, you sent it to L2, and then you would just look at the list itself to tabulate. But then when we did the CDF actually did the tabulations for you. Same thing. Okay. So what you're able to do here is we can take a value. That looks like this. We're talking about surveys. And according to a survey conducted by the Harris Poll, which I guess is a big thing, I've heard of it before, 29% of adults in the United States say that they or someone in their family plays soccer regularly. You are conducting a random survey of 238 adults. What's the probability you will find at most 55 adults who come from a family in which someone plays soccer regularly? Now, the number of trials you have here is 238. They would consider that large. Okay. So here's what it looks like. Your end value would be 238. What's our p-value? What's our probability? I was looking at the 9 at that same time.
0.29.
And now, think about what you want. You want a k-value of success to be at most 55. So isn't that a k-value less than or equal to 55?
Yeah.
So what they were telling you to be able to do here is that by going through the old, taking the square root with all the standard deviation junk, they still had to do all these calculations. You have a button that does binom CDI. You can tabulate this value in like 6 keystrokes.
So do you do the 238, then the 0.29, then the 55?
Yeah, so it would be a binom MCDF. For those of us that don't know where that is, to get to the binom, the other day when we first looked at that binom PDF one, we hit catalog and scrolled through. I found out where it was because I Googled it. Second, bars. And then move up, it's quicker.
And since less than or equal to, do I have to do the 21 or?
No, you should just hit 55. Now, does anybody's screen look like mine?
Mine.
All right, you're okay with it though, right?
Yeah.
Okay. I know that we're better than everybody else. It's very true.
Mine does, too, but I've got calculator.
So you're not better than anybody else.
He never had his calculator.
Okay, you're okay then too.
We'll see.
Yay! So our trials here was what? 238?
It's like that in the first, you just press it. and you get
Our
it.
p-value was 0.29. X value is 55. And it's automatically putting that in there for you. Your calculator, what you're going to do is you hit that Bino CDF, it automatically opens up a parenthesis. You put in your n value first, comma. The comma is above the 7. It took me 10 minutes to find it and ask Mr. Fontana. I had no idea what it was. It was our probability.
Oh.
0.29, then comma 55, and bada bing, bada boom.
Wait, I'm confused.
So our test probability is just testing our probability.
Pretty much. Yes. You have to put in that order. The order it goes N, P, K.
Wait, Mr. Murphy?
Yes, ma'am.
Wait, never mind.
Good conversation, Phoebe. I'm glad we had that. It's a good moment.
Have a lot of images.
Yes. Good question. No, I know what you mean, the K value.
Wait,
Emma was just asking a clarifying thing here is, when your K value is greater than or equal to, that's, if it was greater or equal to 55, you do 1 minus,
did you get this?
Answer that.
no, you have to set it at 54.
Oh.
You want everything below it.
Mr.
Yeah,
Murphy?
yes, ma'am.
My calculator is not giving me that.
Oh, you do a complement, right, makes sense.
So I do
And I
1
put it
minus.
in, I tried it twice.
So solid is
If I did anything wrong.
You have 54, it's supposed to be 55.
Oh,
Jesus
like this. Like
For the
this.
last two questions.
You got PDF, not CDF. Okay. Does that make sense about when you have to use the 1 minus versus the 1 or not?
Yeah. So you always just go one less?
Yes. What happens is, let me explain this again, guys. The calculator, when you're using the Bino MCDF function, it's N, P, K. All right? For when K is less than or equal to some number. Okay? Now, if it was spun around and it was, your K value was greater than or equal to some number, what you would have to do is the following. 1 minus the Bino, oops, MCDF of N, P. Now, the K value, it's going to be K minus 1. All right? So if it was 55, and when I do this version, it would be
54.
54.
So you leave the 250 whatever it was in the 59.
Yeah, I did it.
What's that?
I like, so you just leave the, because like when you wrote it before, you wrote 1 minus K. So like you keep the N and P.
Yes. Yeah. Yeah, and a lot of times what I would do is I would figure this out first and then do 1 minus answer. That way I don't screw something up. It's a little bit easier just to make sure you get it right. I'm sorry, what were you saying? Good conversations. These are great questions.
Is there a way that you can do it where you keep K and N the same as P?
I don't know. Sure, I mean, I don't know what that would give you, to be honest with you, because then you're looking at number of trials and your successes to be the same. And then you're,
Well, could you just change, you do the opposite of K and the opposite of P?
what would that give you though? I don't either. So think of it this way, if you're surveying 10 people and you want all 10 of them to agree to something, well, you have to come up with a probability of an agreement, you know what I mean? So in here, what was the one we did with, what did we do? Oh, it was UFOs. Remember we did UFOs?
Yeah.
So we did UFOs, and it was a 37%,
Yeah.
37.5.
37.
It was 37%. So we had a 37%. And then how many people were here? Was it 25? 4, 8, 10, 12, 14, 16, 18, 20.
I remember it was like 0.4 as opposed to 0.6.
So if we want to have success of at most everybody agreed. That would be a bino. I don't know what that would.
25, 0.37, 25.
Yeah, what does that give you?
1.
Really?
Yeah.
Huh. Well, it makes sense because it's what's adding up everything underneath the curve there. So everybody believed in something. Yes. If you want everybody to believe in the fact that there are UFOs out of everybody in the room, wouldn't that have to occur at 100% of the time?
I am lost.
That's all it was.
You really just messed with me.
So I don't think he does you any good. But I could be wrong. Not very good at this whole math thing sometimes.
Me either.
And I got hit in the head. Lost some things.
How's the eye feel?
Better-ish.
Did you ice it more yesterday?
Got hit with back.
Wait, does ice only help if you do it right after? Or like if you ice like the day after, does it help right after?
Played baseball. I iced it up. I probably should have iced it longer than I did, but
I don't like ice
Oh,
cream.
great
But I
day.
mean, yeah, I think it looks tough.
So.
It does.
I think it looks tough. You look like Mike Tyson. You look like his tattoo that goes around it.
You know, I was going to go for that look. I thought about, saying, hey, wife, mind if I go get a face tattoo? Don't mind. Come on. I got hit in the head.
You got concussion? Are you okay to teach her?
What's the conduct? Someone hold my arms up so I can do that, right?
This one.
How many videos are we holding up?
I don't know. Take a minute and do those. You're kind of doing the same idea. Notice that you're looking at a survey of a large sample. That's kind of the idea that when you see that, that's the hint that you should try to use the CDF. Okay?
It's when you have a large.
When n is large.
So.
All right, on the first one here, you've got the probability that 15 or fewer are colorblind. That means your K value is going to be less than or equal to 15. So it's nothing more than bino CDF of, was it 460, comma, 0.02, comma, 15. That actually gets you that.
How do you do 18 though?
I want to look at parameters. This is where you have to start to learn how to, what is it asking? The second one, you've got the probability that 12 or more. So this is when, for 17, it's your K value is greater or equal to 12. Are we okay with that?
Yes.
Your calculator will do the work summing from 0 up. So what you're going to set it to is going to be the bino MCDF 460, comma, 0.02, comma, 11.
Oh, wow.
Now that's going to sum everything from 0 to 11, but you want everything else, so it's going to be 1 minus that. Okay?
What's the guys?
Because this, in terms of the numerical, the CDF thing adds it up from 0 to whatever you tell it to, and then everything else is left over, and since this is all probabilities, it's got to add up to 1. So it's just the complement. So here's your complement of this. The last one, I really like these last ones. They do this.
Okay. And I didn't even remember that.
I think I kind of get this.
If you think about what you're doing, if you want to go between what Maybe I was hanging out in the bathroom. Think about this in terms of a number line. Just for idea, this is 18, this is 6, and this is 0. Just squint, it's fine. I got hit in the head, cut me some slack. That excuse is really going to get old fast.
Yeah.
Now, what that Bino's CDF is going to do, it'll get you everything from 0 to 18.
Oh, and then you subtract.
And then I can subtract everything from 0 to 6, and when that leave me,
Okay.
that's how that works.
Wait, so what's the
What do? You're basically going to do this. You're going to do the Bino MCDF 460,
We're gonna do 18
comma,
first, right?
point, yes. Oops. You're going to figure out what that value is,
Gotcha.
because that's going to get you from 0 to 18. Everybody okay with that?
Yeah.
Now, if I subtract the Bino MCDF of 460, comma, 0.02, comma, 6, it'll subtract out all these values, won't it? Therefore, leaving me that.
Do you have one minus?
No, because I'm going from 0 to 18, and then I'm subtracting out the 0 to 6.
Okay.
Does that make sense?
Yeah.
I think I saw 0.81.
Sure.
Yeah. 0.8108.
That's about as, to be honest, I can't think of anything, I don't know what else could be any trickier than that, really. Would you get point what?
81.
When they do it, now, just so you know, if you check the stuff in your book sometimes here, this CDF is a very close approximate of what they're telling you to do long form in the book. I'm not going to make you do long form in the book because there's a but, okay? I really don't find the need of having to work that formula. The book had it at 0.839, so it's within hundredths, okay?
Ours is
It's
about-
close, it's just, we're approximating it using the binomial distribution because it is set as a binomial distribution because it's large. But when you approximate it, you're going to have what they call rounding error. Ish.
Okay.
We're right, so.
Yeah. Well, it's important.
Treat
us with
All right, so this is what, page 750, the same stuff?
Keep it on the same page.
Sure, yeah, please, keep it on the same one here. Let's see, so we'll do numbers 38 through... No, we'll start at 30. We'll start at 44, and we'll go to 55. All right? We'll do that.
You know how we're going to dance course on Thursday?
Yeah.
We're scheduled to take our.
Is that okay, guys?
Well, I am.
All right. I'll put it up here.
I was 6 for